of the model of the universe transitioned from the geocentric to the heliocentric model over time. The heliocentric model places the Sun as the center of the solar system and the planets orbit around it. The geocentric model has the Earth at the center of the solar system. The philosophers that supported geocentric models are Eudoxus, Aristotle, Claudius Ptolemy, and Tycho Brahe. The philosophers that supported heliocentric models were Aristarchus, Nicholas Copernicus, Galileo Galilei, and Johannes Kepler.
Eudoxus' model, the universe was composed of Earth and 5 other planets that are visible with an aided eye, namely Mercury, Venus, Mars, Jupiter, and Saturn. Eudoxus was considered as the first astronomer to explain the retrograde motion of the planets in the sky. He found out the difference in the motion of each planet that should be considered to give an accurate description of the universe.
What is retrograde motion? Retrograde motion is an apparent change in the movement of the planet through the sky. Planets are apparently changing direction during the year.
Aristotle supported geocentric models. He patterned to the models of Eudoxus. It shows that the universe was spherical and finite. He also perceived that Earth was the center of the universe and was stationary. He believed that the Earth is too big to move, thus it could not rotate. Other celestial bodies was built up symmetrically in concentric spherical rings, moving around the Earth. People believed the Earth was composed of 4 elements: Earth, water, air, and fire. Beyond the Earth are the planets and the Moon, which revolve in spherical rings. He further described that each ring was in physical contact with one another, which means the motion of a heavenly body in one sphere will affect the motion of the nearby heavenly body. Aristarchus of Samos, Greek astronomy who made the first attempt to create a heliocentric model of the universe. Aristarchus' model, the Sun and the fixed star were at rest while Earth and other planets revolved around the Sun in the circular path. Aristotle and many philosophers do not agree with this, since the star did not show parallax during the year, which they must if the Earth goes around the Sun. Stellar parallax is the annual shift in the apparent position of the fixed star. A moving Earth should produce stellar parallax. This means the star position in January is different from its apparent position in July at the same year. Distant star with smaller parallax, while closer star. So Aristarchus argued that the stars were very far away, thus no parallax could be observed. Since stellar parallax is the only detectable with telescope, his accurate prediction was probably at the time.
Claudius Ptolemy model. Earth was at the center of the universe, while the other celestial bodies revolved around the Earth in a perfect circle with constant velocity. This model was considered more refined than previous geocentric models. This model could explain the motion of the celestial bodies accurately. Ptolemy assumed that planets revolve on epicycles or small spheres which move around a different or large sphere. In this illustration, the red planet revolves on epicycles, the small green circle which in turn revolve around the large blue circle. The center or Earth of the different is called the eccentric. As seen on Earth, the movement of planet eastward is direct motion, while the movement of planet westward is retrograde motion. During that time, Ptolemy's epicycles has offered the best explanation to the retrograde motion of the planets. The planets revolve in Ptolemy's epicycles only during the months when the retrograde motion can be
supported geocentric models. Danish astronomer who also made planetary observations. Brahe believed in a geocentric universe, but his idea of the geocentric universe is slightly different from Ptolemy's model. Brahe's model is the ecliptic system. Earth was the center and the sun and the moon revolved around it. And all the other planets orbited the sun.
Nicolaus Copernicus he supported the heliocentric models. During the 16th century, Copernicus, a Polish astronomer, revived the heliocentric models of Aristarchus. He was hesitant to publish his finding because he was afraid of condemnation, but it was published a year before his death. He strongly believed in the heliocentric models because there were loopholes in the Ptolemaic model in terms of predicting the position of the planets. Heavenly bodies exhibited constant circular and perpetual motion along the epic cycles. The order of planets from the Sun is Mercury, Venus, Earth, Mars, Jupiter, Saturn, and the fixed stars. The Earth is constantly rotating on its axis while it's continuously revolving around the Sun.
Also, now the heliocentric models can clearly explain the retrograde motion of the planets. Since the Earth revolves faster than Mars, there are times that Mars seems moving backwards. However, the Copernican models was still not accepted because the movements of the Earth cannot be observed. The model is also still unable to explain stellar parallax.
Galileo Galilei, he also supported heliocentric models. He invented the telescope and proved the Copernican hypothesis, and also Earth rotates on its axis and revolves around the Sun. The very distant stars do not exhibit parallax. Galileo's models. The Sun is the center of our solar system. Our solar system is a part of a larger universe. He used the telescope to view parts of a solar system in motion.
Galileo's observation: new stars or Milky Way made up of stars, mountains and valleys on the moon, 4 moons orbiting Jupiter. The 4 moons orbiting Jupiter are called Io, Callisto, Europa, and Ganymede, phases of Venus. Sunspots are rotating around the sun about once a month. In the rings of Saturn, planets are disks, not pinpoints of light like the stars.
Geocentric models. A German astronomer who lived about the same time as Galileo. Kepler's model showed mathematically that a sun-centered system works well if planet motion is along off-center ellipses.
The 3 laws of planetary motion. Laws of ellipses. The path of the planets about the Sun is elliptical in shape, with the center of the Sun being located at one of focus. Law of equal areas. An imaginary line drawn from the center of the Sun of the center of the planet will sweep out equal areas in equal intervals of time. Law of harmonies. The third law of Kepler's planetary motion shows the relation between the length of the semi-major axis, the elliptical orbit of the planet in its time period of one complete revolution around the Sun.